Hello everyone. In this lecture, we are going to see feature engineering in machine learning. Yes, firstly, let me say it in simple terms. Feature engineering. Nothing but we are going to manipulate the features of a data set. What do you mean by features? Attributes. Nothing but the different columns. How those are decided based on your type of data. Either it can be qualitative, quantitative. Again, in qualitative, we are having nominal, ordinal. And in quantitative, we are having interval and one more is ratio. Based on your data, how you are going to separate, we are going to see in this complete feature engineering in machine learning concept. So, now let me begin with the process. Yes, you can see feature engineering, right? Now let me jump to the topic. Yes, what is a feature? Attribute. These are, yes. For example, this is your data set. Here this sepal and sepal with petal with species are there, right? Those are known as attributes. Actually, species is the output one. This one you are not going to consider. This remaining four you are going to consider for feature engineering. So, yeah. Again, in feature engineering, there are two types. One is feature transformation and feature subset selection. By the name itself, you can understand that here you are going to transform data from one format to some different format we are going to get. And in the second thing, you are going to select only some part of the data. So we will see one by one. So yes, coming to first thing, feature transformation. Transform into a new set of features. Nothing but we will perform some operations that is only known as actually feature engineering concept, and thereby you are going to get some updated one. Here you can see again in feature transformation there are two types: feature construction and feature extraction. Construction means new features you are going to construct. Extraction means from the existing features you are going to extract the new features. Yes, here you can see construction, right? Construction indicates simply you are going to add new features for the already existing features. It means you are going to maximize it. Here, for example, length is there, breadth is there, and price is there. You are going to also calculate the area because price depends on area, right? So, by you know that area is nothing but L into B and all. So, you are going to perform it and you are going to get a new feature, nothing but one extra column. This concept is known as feature construction. Again, in feature construction, oh, I came forward. Yes. Again, in feature construction, we are having various types. Let me discuss one by one. First thing is with respect to the nominal, nothing but encoding categorical. Yes, this is also encoding categorical, but this is the with respect to ordinal one. Yes, nominal, ordinal, and this is for continuous one. Yes, those are the three types. Let me show you one by one with example. Firstly, nominal. Nominal, as I already told you, there is not going to be any order simply. Here you can see city of origin, right? Like here, city A, city B, city C. Again, parents athlete, chance of win it is given, right? So now, how you are going to divide them? Again, with respect to values, you are going to enlarge it, guys, for nominal. Because we are not having any order. You can't say either this city is great, this city is great, like that you can't say. Nothing but you will say popular based on something. But here we are not going to focus that one actually. For example, let me consider simply I am providing virtual internship, guys. I'll select the member with skill. I don't want his city actually, whether he is from Hyderabad or from Delhi or Mumbai. I ignore those things. So that does not comes under order. That part is called as nominal, as you are already aware of. Yes, if you observe in origin of city, we are having only city A, city B, city C. So one H column is fixed. You are going to have origin city A and origin city B, origin city C. Now again in parent setlet, there is yes and no cases, right? So again, with respect to parent setlet, yes you will create, no you will create. Again there is one more thing, right? Win chance. In win chance again we are having yes and one more is no. So you are going to make them. So now all the values will be boolean, either 1 or 0. Your city A is valid for what cases? Age 18 and age 19. So only for the valid things you will give and 1, and for invalid you will give as 0. Similarly, your parent setlet yes for whom it is a yes. Here we are performing with respect to yes. So yes, wherever it is present, nothing but for 18 it is there, 23 it is there, 18 and 22 it is there. So totally 4 you are giving yes. And for no you are keeping 0. But this is completely vice versa. Either you can directly replace them. If 1 is present, enter 0. If 0 is present, enter 1. But how you are going to perform is with respect to no you are doing. So wherever there is no, there you need to keep 1. For 20 and for 19 you are going to keep 1 and remaining 0. Similarly for win. But from this, how you are going to remove some, you can ignore some cases. Nothing but this ABC you must and should keep as this. Here for yes, here for this yes, anyhow it is having no also, right? So you can ignore this second table. Or if you consider with respect to no, then ignore yes. That's the meaning. The dummy features have value 0 or 1. For features having two values only, can just leave one feature and eliminate the other. Here it is having three values. That's the reason we need to consider. Yes, since only two are existing, you can ignore one. And you can keep no also. Here in example, we have considered by keeping yes. If you will keep no, then ignore yes. That's the meaning of this encoding categorical variables. Now encoding with respect to ordinal. Ordinal means we will be having some order, right? So you are simply going to replace. Here if you observe, these are the marks in different subjects and you are going to give grades, right? You know that ordinal is nothing but ranking. As I told, grade A plus O, B, C, D and all. O means first position, like that we know, right? Similarly, here we are going to replace them with the actual things. For example, if for reviews form I will take, for excellent I will keep the number as, in terms of rating I will keep as 5. For very good I will keep as 4. For good I will keep 3. For poor I will keep 2. For very poor I will keep 1. In the similar way, here for grading system they have considered. Wherever it is A, give it as 1 as it is according to order of grading system. A is given first prior. For B, second. C third and D as fourth. That's the thing. Now this is for continuous thing. Continuous here is nothing but some ranges, nothing but intervals as I have already mentioned. This is the area, this is the amount pricing guys. But here for amount, there will be different ratings, right? For example, let me say from 10 rupees to 1000 rupees it is low cost. From 1000 to 1 lakh it is average cost. And more than 1 lakh it is high cost. In the similar way, here we have given price gradings are like high and low. It is nothing but here you are performing two things. One is just you are converting to categorical, yes, or sorry, this numerical one you are converting to categorical, and from this again you are converting to here categorical nothing but ordinal. From ordinal you are again converting to numerical, and in numerical you are going to give values in terms of ratio, not intervals. That's the concept of this numeric features to categorical. This is completely about feature construction technique. This is completely theoretical part. Yes, this is for working with the text documents. Here we are going to divide them initially into tokens, and all you are going to arrange in terms of lexicographical order, nothing but the dictionary order, and you are going to store the count with respect to document 1 and document 2. And is present, no, right? It is present two times. Like this, you are going to enter the count, and for that you are going to perform normalization. How are you going to perform normalization? Once you add all these terms, 2 plus 2 4 plus 2 6 plus 2 8 9 10 11 12 actually. Here by squaring and adding we have performed nothing but for everything normalizing we will keep in denominator square root of square summation of squaring of all the values. Nothing but 2 square plus 2 square plus 1 square plus 2 square plus 1 square. Nothing but 4 plus 4 plus 4, 12, 13, 14. Here if you observe, square root of 1 square plus 1 square plus 1 square plus 1 square. Nothing but 4. Square root of 4 is nothing but 2. So this is how you are going to normalize. This is how with respect to textual data we are performing. Yes, this is the feature extraction and feature selection. Yes, now coming back to feature extraction, we are going to extract only the sum of the features. Like you can manipulate them actually. Oh, it went somewhat forward. Yes, feature extraction is nothing but from original data you are going to extract some of the features so that the data will be reduced. That's the simple meaning. So let me go to next slide. Yes, here if you observe, feat 1 is the calculation of by making use of feat A, and feat 2 is for ABC. So you are going to ignore those features, right? For example, if let me consider, if I will consider the student's performance, there will be many features like mid 1, mid 2, assignment 1, assignment 2, sem 1, sem 2 results and all. In simple terms, I will calculate for every year average and I will store as first year performance, second year performance. That's the meaning. Here you can see we are going to use the different concepts like boolean or nominal or min max addition subtraction average concept and all you are going to use, and you are also going to use these things, right? Principal components for dimensionality reduction, here we are going to use it actually. Principal component analysis we are going to discuss as an algorithm, so I am completely skipping this concept for now. Variance and all you are already aware of. Variance and covariance difference. Variance we are going to do for a single attribute. Covariance means you are going to perform with respect to two attributes. One is x and one is y. Yes, that's the meaning here. Covariance matrix. Yes, these are all the things related to mathematics actually. Matrices and they're all you can see eigenvalues, eigenvectors and all. This is completely principal component analysis. This we will discuss while discussing about each and every algorithm individually. I am going to discuss. Yes, yes. Now, feature selection extraction is done. Sorry, feature construction and extraction. Now we are going to see the feature selection. Selection. By the term itself, you can understand that you are going to select the features. How? There are four approaches: filter, wrapper, hybrid, embedded. Filter, by the name itself, you can understand you are going to filter out. So by using some of the statistical approaches, those are Pearson's correlation, by correlation concept, chi-square, ANOVA concept, analysis of variance and all, you are going to use it. That's the first approach filter. Wrapper is nothing but here we will perform like wrapping up of data, you can say. Here you are going to identify best feature subset. Yes, and in this selection you are going to perform by considering the multiple subsets and you will consider the optimal one. Same, yeah, hybrid is the combination of both filter and wrapper techniques. And the last one is embedded approach. In that approach, it is somewhat similar to wrapper, but it also uses an algorithm to evaluate the generated feature subsets. It is the advanced version of wrapper approach, you can say in simple terms. Yes. Measures of feature redundancy are correlation, distance, and coefficient based measures. One by one, we will see. This is the correlation based techniques. Actually, these all are not required. Yeah, distance based is important because while working with the clustering concept, there we will consider the different distance measures. Euclidean distance, Manhattan distance, and one more thing is Minkowski distance or cosine distance. There are various distances, but we are going to work. Yes, one more is Jacob coefficient, nothing but is Jacob distance. Multiple concepts we are going to see, guys. You need not worry. While discussing unsupervised learning, I am going to cover these things. Yes, this is correlation based and all. Yes, all the things are covered. Yes, cosine similarity, nothing but cosine distance and all. That's all for this lecture. With this, we have completed the feature engineering completely. And from the next lecture, wait, just let me close all the applications. This is the schedule. Yes, the topics which I covered are, I am marking them in green color actually. Wait, the text is changed. This one I need to change. Yes, so all the covered concepts you can mark with this green color. Processing is done, feature engineering is done. The reason why I came this one fast is this completely is theoretical path. So with this the main theory is over. Now what we are going to learn is this NumPy basics and this pandas. These two packages we will learn. Then again we will come here. Here I will discuss supervised learning concepts. One algorithm theory if I have discussed. And in similarly in ML with Python playlist, there we will discuss with Python programming by taking the numerical data set and one more is the textual data also we are going to see. Hope you all understood and if you are facing any doubts, feel free to contact me or drop in the comment section. In next lecture, we are going to start the NumPy basics. Hope you all understood. Thank you.